Before I introduce one or two examples, I want to introduce Hooke's law. And right now we have known that Hooke's law is for one-dimensional so far, we have known Hooke's law is for one-dimensional model. So that means for these material models, without Poisson ratio, we only know the E, A, and L. Hooke's law is given by this, the stress equal to E times strength. This is for one-dimensional model. And for this model, no Poisson ratio. Is included. So that means we didn't consider the influence on the lateral deformations. But in practice, we must consider the lateral deformations, or that is due to the Poisson ratio effect. Okay, so that means in practice we consider is 3D model. So once we consider Poisson ratio, that means we will broaden our consideration or description of the problem more practically. So in this case, the elasticity or relation between the material will be described by this. Probably I will try to not to write too low too low here. Try not to write something too low, because the people sitting in the back, they will have a hard time to see. So like I'm going to, have you done that yet? I'm going to erase this one very frequently. So for here, we consider a general a 3D material model. And now I'm going to draw in terms of the cube for example. And for this cube, let me designate the corner systems, for example, X, Y, and Z corner systems. And now in these corner systems, and the material model could be loaded in any of the directions or from all the directions. And for example, this material could have the loading that is in the X directions. So for example, in the X directions, it would have the loading. For example, let me call this is Px, is a point loading on the back side, and again that is a force in balance. Okay, so this is equivalent to, for example, to help yourself, that is pretty much is our model we look at from here, that is Px we're looking at here. And then this model will be deformed in this way. For example, if we project to our eyes looking like this, okay, not only we have an axial deformation, but also we have a lateral deformations in other two directions. So now simply I want to write it down. What is each quantities for each of those deformations? We can write it down carefully. So let me write it up like this. The loading is here we have the loading in the x direction, we call the px. So therefore the px will induce, dividing the px by the cross-sectional area, that we will have the stress, and which is in the x direction called the sigma x. So simply here is this px divided by A. For example, let me assume the cross-sectional area in each direction is equal to A. So that is sigma x, okay, something like this. So that means in applied axial direction, we have the corresponding normal stress. Calculation of the normal stress basically is based upon chapter 1. Okay, chapter 1 like this area, like this formula. And now we want to calculate is the strain, which means I'm going to describe what is the deformation here. For the strain, we have to describe the strain in all the three directions. The first one is in the axial direction. Right now, again, in our axial direction, per definition, the axial direction is where the loading applied. So right now, for this case, is x direction. In the x direction, the normal strain equal to that amount. And that amount basically equal to our Hooke's law, sigma x divided by E. Right? Because for our generic model, we know that sigma f equal to E times epsilon x. Okay? And now in the lateral directions, for example, for this case, we have lateral direction in y direction and also in the z direction. And due to Poisson ratio, we will have induced dimension change in the both lateral direction. That is how much? Poisson ratio. By definition, nu equal to the magnitude of the lateral strain divided by the magnitude of the axial strain. So that means the lateral strain so that is equal to nu times the axial strain. Right? Magnitude. So for this case, this is a lateral strain. In magnitude, that is equal to nu times the axial strain. What is the axial strain? This one, right? And this one, how about let me replace by this one? Are we okay?